Yep.
All right. So here
All
we are
right.
here tonight, October 18th, talk about the area model, that important, I'm going to call it a tool that is, it's not new. It's been around for a while. I believe the ancient Egyptians and Greeks even used the area model. I'd have to check my history of math book. But we are here tonight. We're very excited to be talking with you tonight about that very important model, the area model. All right, Ryan,
Yep.
we're going to go
So,
through this one.
um, yeah, so this is our plan for today. I'm going to start kind of in the elementary grades, and then right as we kind of get to the fifth, sixth grade area, or your fifth, sixth grade time frame, Mark's going to take over and take the area model a little bit further. So I'm going to do single digit multiplication, how that can help us learn some of the properties of multiplication with area model, and then finding factors. And then the key one here is how can we connect the area model to the standard algorithm or to all the CRA, the concrete, representational, and abstract. How do we make a connection between these models so we can get them to that abstract level? And then Mark's going to, like I said, continue on and almost repeat some of those. He's not going to do single digit multiplication, but he'll repeat some of those things, but more at a higher level, right? And you can see how this all goes and connects. The last thing there is says Google folder, bit.ly, Brainingcamp _ area. This is where Mark and I have put all of our information, all of our notes, and all of our things that you're going to need into Google Drive, and you will have access to this. The very first one on the top there, it says area model share codes. We've already made these codes. We've already done this. We've already created the slides and created the things that you're going to need. We'll show them to you. But if you wanted to come back here and take one of these codes, type it into that share code box, you will have the exact same page, and then you can use it in your class with your kids or your fellow teachers or whoever. So all of that is available to you. And then there's a few other things in there, more Brainingcamp focused, how to make share codes, how to do this, how to do that. And we just wanted you to have those in case you needed them, in case you wanted. They're also on the website, but know that they're here in this folder for you. So you'll see that Mark put the bit.ly link in the chat. So you're more than welcome to copy that and have access to this file.
All right. Yes, because Ryan and I are both former teachers or math coach, and we want to share what we've put together because we know the power of these virtual manipulatives. Melanie, I will in a moment. I will put the entire link so that you can access it through your school device. All right. So, as Ryan said, we're going to be talking about the area model tonight, and there was an article about the area model in Mathematics Teacher Learning and Teaching in March of 20. And again, I have a link. I'll put that link in the chat. And that article, really wonderful article, really talked about the power of the area model. And within that article, they shared this graphic, which is intended to show all those connections of the area model to these concepts of, Ryan talked about single digit multiplication, multi-digit multiplication, factoring, fraction multiplication, although we're not going to talk about fraction multiplication tonight, algebraic expression, binomials. Not going to talk about derivatives or the product rule. We may see something about completing the square. If you're interested in that, that'll be near the end. But again, it just showed the importance and the power of this model, the area model throughout mathematics and throughout our curriculum. All right, so I am going to stop sharing, and I am going to tell you that Ryan is going to get started. And I'm going to tell you from the bottom of my heart, Ryan is one of the most, if you want to learn how to use manipulatives creatively, Ryan is he is the best person you want to listen to or come and see when he does presentations. So there you go, Ryan. It's all you. And
Now I got to do
I will
good.
get Melanie that link. Yeah.
All right. Wow, set me up. All right. So the very, very first thing that I wanted to do was share one of the codes that are a little different way you can use a code, right? I wanted to kind of level set our understanding of the area model, what it is, what it looks like, and how you could use this in your classroom. So if you have the PDF that has all the links or all the codes to it, I am going to just type this in here. It is NL6HS7UC. And I have to apologize. I am in a hotel working on a single computer. Normally I have a couple screens open that I can drag this stuff over. But what I did here was I just came into Brainingcamp, went into the color tiles, and I made an anchor chart, right? So Brainingcamp doesn't need to be a tool just to teach math. What you could do is make an anchor chart here that you can then share with everybody, and they can take this, they can print it up, they can give it to their students, have it put them in their notes. But really, just to kind of understand what we're talking about with the area model, is anytime you use a rectangular shape to show what is happening in multiplication. So you have two factors in a multiplication problem. One of the factors is going to be the length in blue. One of the factors is going to be the width in green. And the area that makes is the product of both factors. And when I saw this, I was like, that's too simple, right? That's perfect for third grade. But then when I went up and saw this stuff in high school, it worked again. And it works every single time. I mean, this is the basic. This can be used for second graders all the way up through high school kids, because this is what the area model is representing. One length, one width, and then the product. And you can go from the product to and have one of the factors, and you can do division, you can do a whole bunch. And we're going to show you all that stuff in a second. So I just wanted you to see that you have an anchor chart that if you wanted to print this up, use this with your kids, you can do that. An easy way to print it is enter that code, come here to share, and here you can copy the image, you can download the image, put it on your computer, put it into a Word document, email it to your kids, email it to your parents, however you want to do that. But yeah, copy the image, download the image, and then you have it. All right, so we're going to start right around second grade, maybe third grade. I said we're going to start with single digit multiplication. And this code is RYX8YZC8. And again, that is found inside that document. And again, I'm on color tiles. And what I'm going to ask you to do, or ask the students to do, is build the array 3 times 6 to show your work. Now, what I did here, just to show you how I did this, was I clicked here. I have this area frame here that comes out. And then once it's on, you can grab this thing and move it around to be whatever size you want it to be. So that's what I have here. Click on the array and then drag that little square to be whatever size you want it to be. So in this case, I'm going to get rid of these because I want the space in a second. In this case, we can actually build 3 times 6 by clicking on the array and then dragging it. So I have a length or a width of 3 and a length of 6. In the area model, I actually just heard this today. In the area model, it does not matter which way you do this. In a word problem, it does, right? So in a word problem, the 3 means something and the 6 means something. But in this situation, one's the length, one's the width. It doesn't matter. So once you or the students have 3 times 6, you can drag these tiles out. I'm just going to put 1 in and then quickly click and see that I have 6 here. I'm actually going to turn on my labels too, because I like the way this works here. Turn on my workspace, and there's 6. And then there's another 6. You can see now I have 12. And then here's another 6. And you see that I have 18. I think most people are pretty familiar with using color tiles, especially the early grades, to build these arrays. But I wanted you to see a nice, easy way that you can do it in Brainingcamp real quick. Another way that you can do it, I'm going to step back a few. And this way, you really do see what's happening is that I just put 6 in, and then I'm going to click and drag just those 6 tiles, and I'm going to copy them. Now I have another 6, and now I have 12. Copy them again. Now I have another 6, and they actually see you are adding 6 3 times. So if you wanted to get into multiplication as repeated addition, 6 plus 6 plus 6. All right. Moving on a little bit here. One of the things I know that teachers sometimes have a not difficult time showing kids, but is the properties of multiplication. And this would be another great spot that you can use this, that I have 3 times 6. The commutative property is A times B equals B times A. So in this case, it's 3 times 6 is the same thing as 6 times 3. So to show that, we could build with physical manipulatives of 3 by 6 and a 6 by 3 and show them they have the same ones. But what I'm going to do is just copy everything. I'm going to grab the entire thing, the frame and the color tiles, and I'm going to copy them and move them over here to the side. And now that I have 2 3 times 6s, I can click on the frame itself and flip it. And just that quick flip, hey, this is the exact same thing. It's a copy. I've just rotated it. Could be that bridge to the kids understanding, hey, it's just turned sideways, right? Now, some people are going to notice real quick, down here it says 36, because when I have on that workspace label, it is counting everything on the screen. So if I wanted to show kids that, hey, these are the same numbers, I can choose whichever array I want, and I'm going to choose this one right here and click on it. And now this time I'm only going to click on or highlight the manipulatives. I don't want the chart. I want just the manipulatives. And when I do that, one of our tools says toggle your color. So I'm going to say green, right? And now it changes and it shows that 3 times 6 is 18 and 6 times 3 is 18. And we can easily show the commutative property using the area model of multiplication. Mark, I don't have my chat up. Am I good to move on?
It looks like it, yes.
Okay, perfect. So then we're going to move on to the next one, and I'm going to build off this 3 times 6 because another property that kids and kids have to do, you need to teach, is distributive property. So I have one here. This one is LZM 9CH5F. And when I hit go, it brings me to this problem right here, which is I intentionally use these numbers. This is 3 times 16, right? I've just added 10 to the previous one, right? What I need is I'm going to break that 16 apart, right? I've left the 3. I've actually turned the labels off on the array. And then I've typed in the number 3, just so I want that 3 to be there. What I want you to do in the chat real fast, tell me one way that you'd be able to break up 16 into 2 digits, 3-digit addition problem that is going to get me 16 that your kids might use to say, hey, I know this fact and I know that fact. And I'm going to pull up the chat real fast, all right? Most people saying 10 times 10 and 6, that's all addition or a multiplication problem. I want addition problems, please, if you don't mind, because we're going to be doing distributive property, and that's A times B plus C, right? Someone said 14 and 2, 8 and 8. All right, 10 and 6 is coming up, 15 and 1. Awesome. All right, so let me show you how you can do some of these, right? Let me write a couple of these down here. Someone said, a lot of people, the number one was 10 and 6, right? Another one that I saw was 8 and 8. Someone said 15 and 1. And I'm going to take one more. And I'm going to use this one because, oh, I see other people doing it. Good. I was going to say everyone's doing 2 digits. Most people doing 2 digits. I see a 4, 4, and 4, and 4. I'm going to almost do the same, but I'm going to do 5 plus 5 plus 5 plus 1. All right. So you can have your kids talk to you about what are ways they can break up the 16. And then we want to show them, same thing. I'm going to turn on this label. I'm going to turn on my workspace label. Actually, what I want to do is turn all these. I should have done this earlier. I'm sorry. I'm going to turn all these to yellow just so the numbers look right, right? And I can say, okay, well, 10 times 6 or 10 plus 6, I know that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then these last 6 ones are ones that I just want to change the color. And we'll turn them to green. And we can see that we have 3 times 10 is 30. And 10 times 6 is 18. Together, that's going to be 48. I'll erase it. And then now I'm going to do 8 and 8. So all I have to do is add 2 more here. And I'm going to turn these, this time I'm going to turn them to blue. You choose whatever color you want, right? And I can show that 8 and 8. Hey, if I know 3 times 8, all I need to do is double it. I can use my double, kids know their doubles. If you know 24, you can double that to get 48. Somebody said 15 and 1, right? Let's see how that's going to look. I can do 15. Well, I got to remember how I want to do this. Okay, 15 over here and 1 down on this end. I can change all the colors if I want, but I know what these ones have to be yellow. So if a kid knows that 3 times 15 is 45, this is only one more group of 3 larger. We can then do the last one, and I'm not going to do the pen. You guys can kind of see that if I said 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, change these colors to blue, 1, 2, 3, 4, 5, change these colors to pink, and then 1, make that one orange. And we can kind of see that, hey, if I know 3 times 5, that's the one that kids know pretty quickly. They learn their 5s quick. So 3 times 5 is 15. 15 and 15 is 30. 15 more is 45. And then all I have to do is add that 1. So again, we could use this area model to show kids, hey, this is an easier way to break this apart and show them the distributive property. There's a reason I want them to understand distributive property, and that's going to come up in 2 more examples. But we want them to be able to start breaking these up into easier numbers for them to use. So maybe they don't need to get out the pen and paper and do all the work. All right. So that article, I was going through that and it got to factoring, and I thought, I don't know about factoring. Maybe I should skip that part. And I thought, no, I'm going to put it in. I can show it. It can show it pretty well. And I'm so glad I did, because then when Mark and I got together and we started talking about our pieces, he was doing factoring. And I was like, wow, this is great. Like, again, here are these connections that we have. So we can use the share code for finding a factor, which is 4KYTG. Lost myself. 5SE. Okay. And when I click on this one, what are the factors of 16? What I did was dragged out 16 tiles and I made them vertical. So we can see that we have a 10 and a 6. So I can represent that number as 110 and 16 for kids who are struggling with that. And then I dragged out some arrays. Now they default into 3x4. And I intentionally left them that way because I want the kids to play around with these and start finding arrays that will equal 16. So again, in the chat, there's only 3. Put in one of the arrays that you know, well, I can make if I had 16 tiles. I'll pull my chat back up there. I see 8 times 2, 4 times 4, 16 times 1. You guys are on point tonight. You got them all, right? You can keep putting them in if you want. So let's start here. Someone said 16 times 1. So I'm going to move this because I need a little bit of space. And 16, that's 15 times 1. So I could build 16 times 1 here. Somebody else said 2 times 8. And again, I can drag this over, give myself the space I need. If I'm crowding the page, I can zoom out and then give myself some more space. We do have a lot of space on Brainingcamp. So if you needed more space, you can do that. The last one is someone said 4 times 4. Okay, so the kids build their arrays. The kids, come up with these frames, these array frames. And then what I want to show you is keep this red one where it is. Don't change this one. But what you should do is copy it. And then just like we did before, change the color. And this one we'll make blue. And then when you drag it, if I put it on that 2 times 8, you see how those blue squares come up? That's telling me when I let go, it's going to fill it up for me. And I can see, yes, I got this one exact because every single square is filled. And I've used all the copy of them, right? So if I copy this 16, it should fit into that 4x4. And we'll change this one to green. And when I drop it in 4x4, I know it works because it's completely filled and there's none left over. And then the same thing, I'll copy this, change the color, drop it into the 16 times 1. Actually, you know what? Let me change it. Let's say somebody builds an array that doesn't work. Let's look at what happens if it doesn't work. If I take this copy and drop it in here, it's still going to let me drop them in. Oh, come on, it didn't. It's still going to let me drop. I got to move faster or slower. There, if I drop it in here, it's going to fill them, but you see that extra one that popped over there? This array doesn't work. So if a kid has an array that doesn't work, then we can say that, hey, that array doesn't fit. And the same thing is going to happen if I go the other way. That if I maybe had, let's step back one, maybe if I had 17 and they take this array and they drop, or they take these and they drop them in, you see I have that blank space. And that blank space tells me this doesn't work because I have an extra space. So having extra space inside, having an extra tile outside, that array doesn't work. Filling it perfectly, we know that we have an array that matches the number. And then from here, I'm not going to get into this, but from here we can start talking about composite numbers. We can start talking about prime numbers. We can start talking about square numbers. Look at the 4 times 4. It is a square. That's where we're getting that name. That's where we're getting that, square numbers can make a square. And now I have all my factors. Here, fix this one. I have all my factors for 16 because I have 1 and 16, 2 and 8, and 4. So I'm going to be able to find all of my factors. All right. I see a bunch of chats. I want to make sure that I'm not missing any questions. Oh, I'm glad I checked it. I'm glad you guys are liking that one. That's perfect. Yeah, and this is so much faster. I remember making this with chart paper and having the kids cut it all out. It was great, but that was a whole lesson, right? This is a much, much quicker in Brainingcamp. All right, so my last one, and I'm going to move on to, I'm going to change my manipulative. I'm going to go to, if this will work for me, I'm going to switch to the base 10 blocks. And I want to show you one of the tools that we have down here in our base 10 blocks. If this is your first time to Brainingcamp, if you're a pro at Brainingcamp, you already know this. But down here where it says workspaces, you can change the backgrounds to allow you to do other things. And when I click on it, base 10 blocks has like the most that you can do. But this one right here that says factors, right? This is the one you want to click on. This pulls up a tool called a factor track. And what you do is take your numbers and drop them into the vertical and the horizontal tray, right? And this is going to get your factors. I'm going to step it up from single digit like we've been doing. I'm going to step it up to do the problem 12 times 14. And I'm going to rotate this and just click to get 14. So now I have my length and I have my width. So I need to find that product. I need to find that area. I can use these tools to say, well, I have a 10 times 10 or a rod times a rod, and that is going to give me a 100. And notice what's happening. I want to just shrink this down just a little bit so you can all see that. As I'm adding these pieces, we will keep track of how many are inside that rectangle, right? If you have a piece outside it, we're not going to count it, but if it's inside, it will. So you can stretch that to be as big as you want. If you need to do 3-digit numbers, zoom out, do 3-digit numbers, right? So 10 times 10 was 100. 10 times 1 is 10, but I have that 4 times. And then I could take this and say, now I have 1 times 10, but I have to rotate it and drag it back to here. And then I can say that, 1 times 1 is 1 4 times. I could do that. And maybe your kids want to see that, but to be quicker, I can say, well, this is really 1 times that entire factor, which is going to be, stay where you want, stay where you are, 14. And I'm going to copy this and I can say, 1 times 14 is 14. So we can see that 12 times 14 is 168. Now, I told you before I get going, I got to move quick, that I want to show you how to go from here to the concrete to the representational to the abstract. So I'm going to do this as quickly as I possibly can. I'm going to copy 4 squares. And I'm going to use my pen real fast to say that this is 10 and 4 and 10, and not right on that, and 2. This is where that distributive property comes in, right? Because I can break that number into a 10 and a 4. And then I just like doing this because color always helps me learn a little more. My images are in the way. Sorry, let me get some. Oh, Zoom's not letting me move the, there we go. Okay, sorry. I like changing the color. It helps me make more sense of it. So 10 times 10 is 100. And I put it in orange because that's going to help me connect this to that model here. 10 times 4 is 40. 10 times 2 is 20. And then 2 times 4, I need to make it yellow, but that's going to be 8. I'm going to continue on here to show you where this goes next, is that if I had 14 times 12, one of the next ways that everyone is shown how to do, many programs do this, is that they do the partial product, that you say, well, okay, 2 times 4. Well, that's 8. 2 times 10. I'm just going to do 2 times 10 is 20. 10 times 4 is 40. I apologize for my writing. And 10 times 10 is 100. Now, when we get to this model, I can connect it to this and say, well, where am I getting that 8? From right here. And this is what it looks like in the concrete model. The 20 is coming from here. This is what it looks like in the concrete model. And then, same thing with the 4, same thing with the 10. And then that's going to help me get to the last one, the standard algorithm of 14 times 12 is 8. 2 times 10 is 20. Well, now I have 28. Where did I get 28 from? 28 comes from right here, 28 comes from right here, and 28 comes from, actually, let me just zoom out. Oh, I know what's wrong. We put a piece way over here. Put a piece over here, recenter it. And now I have all this up on the same one. So the 28 comes from here. The 28 comes from right here. The 10 times 4 is 40. 10 times 10 is 100. Again, where am I getting that number? From these numbers here and from this part of the concrete model. And when I tally all those up, we get 168. So I can see that the area model will help me lead to that standard algorithm. All right, so that should get us up to about the 5th grade time, 5th grade, 6th grade, because again, you can stretch that out and do 3-digit numbers by 2 digits, 3 by 3. You have all that space that you can use, right? Mark, one of the questions is a way to make your boxes for 40, 20, and 8 size to match the quantity.
Yeah, I'm going to show that right now before I get started.
Awesome.
So if you go up here in what I'm going to call the toolkit, click this icon right here, go to my shapes and tools. I can drag out this square, and then you see once it's selected, I've got these other squares. Now I can drag those.
Oh, to make them
if
longer.
If I drag the corner, it keeps it proportional. If I drag the side, it keeps it non-proportional. So that's how you can change those. And pretty much once you get anything, any object on the workspace, once you click on it, you'll see a series of menus and options. All right. So let's go to, so we said we'd talk not just about the area model in terms of multiplication. First, let me back up. Hopefully you realize I didn't lie about Ryan. He was pretty creative and pretty thoughtful on his use of manipulatives. And I was following things in the chat. So I was able to, sounds like you agreed with what I said earlier. All right. So let's take a look at an area-based manipulatives. Now, right now I'm in algebra tiles, and this is one of my favorites, right? Because I think there's they're very powerful, but I also think there's time that's needed to get the geometry of the pieces together. So I'm going to take out this yellow piece, and I'm going to say, let's all come to agreement that if this side length is 1 and that side length is 1, I'm going to go kind of fast here. We could say that this area, that this piece is equal to 1, right? So if that is equal to 1, then we can start to talk about these other rectangular shapes, right? What might this green rectangle be representing, and what might this blue square be representing, right? So I like to think about the geometry, right? These dimensions right here, these dimensions coincide. So I can say that this dimension on this rectangle is 1. But now the question is, what is this dimension here? So as I'm introducing these tiles to kids, you know that they're gonna take these and say, well, I can put those, match those dimensions, and I can see that it's it's almost 4. And then you can have some conversations. Yeah, but do we know exactly what it is? And we can say, no, we don't know exactly what it is. So what do we do in mathematics when we don't know what something is? We'll give it a variable name. We'll call it X. All right. Now, what about this blue square piece here? Again, I am going to look for when my dimensions coincide. And I can say, okay, the dimensions of this is, well, I know what this piece is. This is X. And I know what this piece is over here, or this side over here. This has dimension of X. So coming back earlier to what Ryan was talking about the area model, we can now say that this represents X squared. And we can do the same things for the other tiles. And I purposely turned off right down here. I purposely turned off the labels on those objects because I wanted us to, I know we went fast, but I wanted us to kind of see where that relationship is or what the relationship is between those pieces. And I could do the same type of things for right down here. I clicked here to get the Y pieces. I could do the same type of getting to know the pieces with the Y tiles. So here is X and there's XY, right? So we can do that same type of exercise with those other pieces as well. We could also put together some shapes and have kids. I'm going to turn the Y tiles off. Have kids determine, oh, what's the perimeter of, let's say, this shape here, right? We could talk about perimeters or even areas, right? We can talk about, hey, we know these dimensions. We know that this is X. We know that this is 1. So this side length becomes X plus 1. Probably looks a little familiar from what Ryan was sharing with us earlier. All right. So I like to spend some time developing and exploring for students before explaining what those pieces represent. Now, so we're talking about multiplication area model. I'm trying to keep an eye on the clock here. I want to go to one of the share codes, and I will put it in the chat. Whoops. When we start to talk about multiplying integers, all right? Put my bad here. There it is. All right. Whoops. That should go to everybody. Sorry, I just sent it to Monica. All right. There we go. Here's a share code. I'm going to take that share code and I'm going to place it in the share code box and hit go. So now, again, using that area model for multiplication, I know that my students, I taught 8th grade math, manipulatives completely transformed my instruction, my teaching, and it really made things different for my students. It allowed me to be more of a facilitator rather than sage on the stage. So as you open that, you're welcome. So as you open that share code, you'll see, remember Ryan talked earlier about the different workspaces. This is the basic workspace. There's also the factor workspace, which you'll see has the factor track where factors meet at 90-degree angles. And you'll notice that I copied them and created multiple versions. So I'm going to go back. So whichever model really works for you, I wanted to include both of those. Let's go back to the basic workspace, right? And following along with what Ryan was doing with, creating those arrays and creating area models. We could model multiplication of integers, positive integers, right? We can model that 2 times 3. We could also model, I'm going to copy this. We could also model 2 times -3, and now I could use the negative pieces, right? So, or I shouldn't say negative, I should say -1 or the opposite of 1. And I can look at this now as 2 groups of -3, and oops, get that there. And what Ryan was talking about earlier, little operator error there. What Ryan was talking about earlier about creating those arrays and commutative property. So by this time, we're probably in grade 6. We're doing multiplication of integers. They probably already know that, hey, if I have 2 times 3, they know the commutative property. They may not know by name, but now they know that, well, that's the same as -3 times 2. So I can model positive integer multiplication, a negative, or let's say a positive times a negative times a positive. But the question now is, what happens when I multiply a negative times a negative? Now, I've seen some videos on the interweb, on the internet, where they treat this -2 times -3 as, well, you have to take away two groups of -3. And as I look at that, I say, I don't see anything that says take things away. So this was an area that my students really struggled with. And so, like I said, manipulatives transformed the way I taught. Manipulatives are wonderful tools, but we have to use them with integrity. And for me to say, well, now I have to look at this and take away two groups of -3, to me that seems like a contrived use of manipulatives. So what I would say is I'm going to think like a mathematician and think about those standards for mathematical practice and think about constructing valid arguments and critiquing the reasons of others. I'm going to look at it as a mathematician and ask myself that question: negative times a negative. Well, what if a negative times a negative is not positive? What does that mean? Let's look. Well, here's an example, right? -1 times parentheses, -1 plus 1 by distributive property, which I know is true. I know it works. Ryan showed us, right? I can distribute that. But then on the left-hand side, I also know, based on my additive inverse property, right, or zero property, that a number plus its additive inverse is 0. So on the left-hand side, I have -1 times 0. I learned a long time ago that when I multiply anything times 0, I get 0. Over here on the right-hand side, -1 times -1, remember, it's not +1. It's -1. So then we have -1 times 1, which we know is -1. We've established that. So now what happens? I get this crazy statement that 0 is equal to -2. So I'm thinking like a mathematician. I'm asking myself that question: what if that's not true? So that means that, therefore, a negative times a negative, -1, in this case, -1 times -1 equals +1. So I think about how can I help it reinforce or implement those standards for mathematical practice. And here, I'm going to go through this part really quick. This is part of what I see as the beauty of mathematics. If I have a sheet of paper, I can take everything I know about math and put it on that sheet of paper. I have those things that I accept to be true, right? The axiom, postulates, definitions. We knew some of those things were true, right? We had established them. Commutative property. We knew additive inverse property, right? And then using those rules of proof, right? But I don't know, when I took high school geometry, it was a lot of two-column proofs, right? Conditional, biconditional, or those rules of inference, proof by contradiction or proof by induction. And then from those things, everything else follows. So for me, that was the beauty of mathematics. And that's when I saw the mathematical practices, that really clicked for me in terms of putting those things together to help kids think like mathematicians and ask those questions about, or ask yourselves questions like mathematicians do, and question things to see if they are true. All right, keeping an eye on time. Let's go to let's go to binomials. In this case, I'm going to go to factors, and let's say I want to multiply. Let's see, x plus 2 times x plus 4. All right, I'm just going to put that up on top here. Again, like Ryan told us, these factors meet at 90-degree angles. So I'm going to build that rectangle, what I'm going to call the product rectangle. Here's my x plus 2. Here's my x plus 4. Whoops, let me get the 4 in there. Let me get the x. Because here's a great time to have that conversation about what's a legal move when I'm using this area model, right? Notice here, these dimensions coincide, right? This would not be a legal move because this dimension here doesn't match that dimension. So I'm going to put this one down here. Those dimensions match or they coincide. Go here. And again, we probably did not learn binomial expansion this way. So we have to kind of play around with it just like we're expecting our students to. And it's important for us to make sure that we're not letting our abstract thinking get in our way. And so now I can fill that product rectangle in, and now I'm going to switch something really quick. Here's what Ryan showed us. 10 plus 2, 10 plus 4, 168. We had that area model. Look what we did over here. So you middle school teachers, your students have seen this before, right? Here it was 10, here it's X. There's the 4. This is 10 plus 4. Okay. What a powerful, in my mind, what a powerful tool to be able to help kids, again, make that connection. All right. I hope I'm not going too fast. I do have, all right, let's take a look at factoring. I'm going to go to another share code. I believe this one is on the PDF document that we created. How many ways can you factor 6x plus 6? All right, so here's my expression. I'm going to select this, copy it, because there is more than one way. I'm going to click on this little zoom to fit button right here, which brings everything in center. And so now, again, I'm going to build build that rectangle. And again, we can talk about what's a legal move, what's not a legal move, right? And I can arrange these. And what might be, I'll finish that. But then what might be another way to factor this expression, right? And so this is the share code that I believe it's on that document. So you can take that, you can play around with that as well. All right. Oh my goodness. Let's go to
illegal move in there, Mark.
I had an illegal move.
Yeah, that's right.
That's because I'm rushing. Let's talk about completing the square. All right. So let's take a look at let's see, x squared plus let's see, what did I want? X squared plus 6x plus 5. All right. So completing the square, right? I never, when I learned completing the square, it was a procedure. It was like, what do you take half the middle term, square it, add it. So you make this this polynomial, this trinomial, you force it to be a perfect square trinomial, right? So how can I make a square out of these pieces? Well, this dimension matches here, those match there, and again, I'm going fast. But your kids, as they're doing this, they're gonna struggle a little bit, and that's okay, right? So now, where does this now? I don't think I've got enough pieces as well. yeah. Somebody's got to keep an eye on me. It's a full-time job, so I can't complete that square, right? So I'm going to take these pieces. I'm going to bring them over here. Shape doesn't matter right there, but now I'm going to complete that square. And again, your kids are going to, they're going to be trying this. I'm going to do some shortcuts here. And you could even talk about, well, how do we know this is a square, right? So I've completed that square. I'm going to copy these, and then I'm going to take their additive inverse. So I've selected them all, make them their additive inverse, because now I have these zero pairs, right? And zero pairs, they don't change the value of what's on my work mat, right? Because we have that identity property of zero, right? Anything added to zero is that anything, right? So we can verify, knowing what we know about the tiles, right? This length, we can verify that that's a square, right? This is x plus 1, 2, 3. And this over here is x plus 3. Now I'm going to turn off this label down here. Turn off my workspace. So now I have x plus 3 quantity squared. But what do I have over here? Well, I need to simplify that. So I can select them all. And now I can create 0 pairs all at once. And I have x plus 3 quantity squared minus 4. So I've completed that square geometrically. I've made that square. And for me, it just helps make that connection so much stronger on that term, completing the square. What does it mean? I never had a visual. I just had the process when I was in school. All right, so we've got 3 minutes. I apologize for rushing through some of those things. I do want to, we do want to take some time to kind of wrap up the benefits of that area model. And Ryan, feel free to turn on your camera and your microphone. There he is. So if we look at the benefits of that area model, one, it visualizes, it gives kids and us, I'm sure, a visualization of multiplication, right? Think of the mathematical practices. It's a tool that we can use, an appropriate tool that kids can use, we can use for multiplication. It helps us make use of the structure of our, I'm going to say our base 10 system, as well as, working with algebraic concepts, right? It helps us make use of that structure. It also helps to make sense of that, of multiplication and what multiplication means. And for me, here's the key. It makes those connections, and to me, it is the epitome of coherence when the Common Core writers talked about coherence and what that means. That it just helps make that connections. It gets that prior knowledge, and just creates such a powerful tool that if you go and you read that article, they even take it a step further and talk about derivatives and product rule. I don't know if they get into L'Hopital's rule and all that other stuff, but just a powerful, powerful tool for us to use, as well as your kids. Ryan, anything that I missed there?
No, I'm just, going back to the things, like I said, Mark, when we were talking about this, and, I know the elementary stuff. That's why I was an elementary school teacher, elementary math coach. And I wish I could go back. Teachers say that all the time. I wish I could go back to when I was in the classroom, or when I was back into the coaching thing, and show the importance of this area model, because I had so many teachers like, I don't want to use the area model. It takes too long. It's too much work. Yeah. But now that I see it, I'm like, oh, if we just will do it in the elementary grades, it'll help in those upper grades. And, once a kid truly understands the area model, there's nothing they can't do with it. And, that I loved when we were planning this, just seeing all those connections and how everything kind of is the same way. It's just with unknown numbers, or larger numbers, or whatever. And yeah, I was like, enjoyed it.